Okay, let's take a look at how to convert between grams and moles. Now this is one of those things that we have to almost get to be where it's like a habit. We just do it without thinking. Because there's so much of this involved in tracking amounts and reactions and what a reaction will produce versus what is necessary. So this is just something we're going to get started with now, and then eventually it will become, like I said, just the language that we speak. The green one here says convert 10 grams of magnesium nitrate into moles. Okay, now the first thing to recognize is magnesium nitrate's got kind of a complicated looking formula with parentheses. So we're going to have to interpret that correctly. What I'm going to do is I'm going to set up my one-step conversion, 10 grams, and I'll write down magnesium nitrate, and it's really important that you don't take shortcuts here. You actually write the correct formula with all of the correct subscripts. Otherwise, it's going to affect how you calculate it and ultimately whether or not you can get an accurate result. I'm going to do a one-step conversion to turn grams into moles. So remember, grams is what we start with, moles goes on top because that's what we want to finish with, and then grams is going to get brought down here diagonally because we want grams to eventually cancel out. Now, we get this information from the periodic table. Remember, the periodic table shows us 1 mole of everything we know of. The atomic mass on each element tells us 1 mole of that element. 6.02 times 10 to the 23rd atoms of that element would weigh that many grams based on what we see on the periodic table. So what I'm going to do is look up the atomic mass. Now grab your periodic table. Let's make sure we're actually looking at the right thing. Okay. You're going to be looking at your periodic table, and we're going to look up the atomic mass of each of these elements, okay? And then we have to interpret the numbers correctly. Now magnesium, when we look it up, it says it's about 24.3. Okay? Now that's not close to a whole number. See, 24.3 is a little bit bigger than 24. It's measurably bigger, so I'm going to leave that alone. Nitrogen, okay, if we look up nitrogen, nitrogen says 14.007. To me, that's really close to 14. If it's right next to a whole number, I'm going to round it to the nearest whole number. If the decimal's kind of in between two whole numbers, I'm going to leave it alone and at least go to the first place after the decimal. Oxygen is 16. Now let's look at how many of these there are. This 2 is really important. What it really means is I have 2 nitrogen atoms and 6 oxygen atoms in this compound, okay, in 1 molecule of this compound. So I really need to take the 14 for nitrogen and have to times that by 2. Okay. So this right here is the 2 nitrogens. Then I take the 16 for each oxygen atom and I times that by 6. And then I have 24.3 over here. I have to add all of those together to get the overall molar mass of magnesium nitrate. How much 1 mole of this substance would weigh. Okay, so when I add these together, I got 24.3 plus 28, because that's 14 times 2, okay, plus 96, because that right there is 16 times 6. And what this is going to tell me is the grams per 1 mole of this substance. So this one ends up being 148.3. 148.3. Oops, I just put that in the wrong spot. Let's get rid of that. 148.3 grams for every 1 mole. Okay, I'm actually glad I made that mistake because this highlights something. Let the units dictate where you put the numbers. The periodic table tells us 1 mole of everything, so 1 is always going to go wherever your moles is. That's what the periodic table represents. 1 mole of everything that we know of weighs this amount of grams. So the atomic mass is added together. This entire sum right here is going to go with grams every time. 1 always goes with moles. Now this basically just tells us we're going to take 10 divided by 148.3 because it's on the bottom. Okay, so 10 on top, 148.3 on the bottom. We ignore the 1 because it doesn't affect the math. And this becomes 0.067. And what does that mean? Look at what's left. Grams cancels out, and I'm left with moles of magnesium nitrate. So I want to label that. Every number has a meaning. We have to write down its meaning. This is moles of magnesium nitrate, and write the correct formula for it. Okay, that's turning grams into moles. Grams into moles. Now let's take a look at the one next to it, because this is going in reverse, and you have to be very careful when you read that you recognize which situation you're dealing with. Like, which direction am I going? Here we have 3.5 moles. That's our measurement, and it's of potassium carbonate. So I'm going to write down 3.5 moles, and we can just abbreviate it with MOL of K2CO3. Now I need to turn that into grams. So a little bit of room here. So mole's going to go on the bottom. Remember, mole goes down here. Over here, grams gets drugged down diagonally because we're trying to get rid of it. Here, moles is what we start with, so it gets drugged down diagonally. And we want to end up with grams as our final result. Now I have to look at the periodic table again. Okay, let's take a look at that. Potassium weighs 39 grams per mole, but there's 2 of those. Carbon weighs 12 grams. Oxygen weighs 16, but there's 3 of them. So that's really 39 times 2, that's 78, plus 12, plus 48. I got to add all those up to get the total weight, the total molar mass of potassium carbonate. So potassium carbonate weighs 138 grams. So that's 138 grams for every 1 mole. 1 always goes wherever the moles is because that's what the periodic table represents. 1 mole of every substance. 1 mole of every atom that we know of. Now, in this case, moles cancel out. I'm left with grams, but I've got 3.5 and 138 both on the top, so they're going to get multiplied. And I'm going to divide by 1, which doesn't change the mass, so we can kind of ignore it. So 3.5 times 138 is going to give me an answer of 483. Make sure we know what that means. 483 what? It's grams of potassium carbonate. That's the stuff that has not canceled out yet. So we put grams K2CO3. These 2 conversions have to become something you just do a lot of, okay? Starting out in chemistry, it sounds like something new because moles isn't a unit we've really dealt much with up until chemistry, but it's a specific chemistry unit you're going to see a lot. So when you see something in grams and we have to convert it to moles, there's a lot of things down the road where this is going to come up. We've got to learn to go from grams to moles and from moles to grams just like that. Just set it up and run with it so that we can do something else with those amounts.